Alright, let's continue where we stop. Analyzing the graph of what? Polynomial function, even and odd functions. A function f is an even function when, I hope you are following, if you are given a function f, if you are given a function f, it's an even function if it is even function. A function f is an even function when f of minus x is equals to what? F of x. So in this case we say that it's an even function for all x in each domain. All x in each domain. For example, if f of x is equals to s raised to power 3 minus 2s minus 3 for all x, if it is an even function, if we put substitute s for minus x and the result is equal to the function itself, then we say that it is an even function for all what? X in each domain. The graph of an even function is symmetrical about the what? Y-axis. And again, a function is an odd function. I hope you are following. It's an odd function when f of x, f of minus x is equals to minus f of x. So if f of minus x is equals to minus f of x, we say that the function is odd function for all x in each domain. The graph of a function is symmetrical about the origin. For odd, it is symmetrical about the origin. For even, it is symmetrical about the y-axis. So we can proceed with examples to clear the air so you can understand the concept. So example 1. State if the function is, we are given a function s raised to power 4 plus 3s raised to power 2 minus 2. Is the function even? Is the function even, odd, or nada? I hope you are seeing it. So, is the function even, odd, or nada? So let us test for even. To test for even function, as we have said, for even function, f of minus x must be equal to f of x. So replace f of x with what? F of minus x. So the first thing is to replace it and simplify. So f of minus x is equals to what? Minus s raised to power 4 plus 3 minus s raised to power 2 minus 2. So this will give us what? Because this is even, this will give us s raised to power what? 4 plus minus s raised to power 2 will give us even x. So 3s raised to power 2 minus 2. So you can now state that, therefore, since f of minus x is equals to what? F of x, the function is what? The function is even. So we have tested it and then it is even. So when we substitute the value of minus x, it is equals to f of x. Is it not? So this value, when we substitute it here and replace it and solve, this is equals to this. Since f of minus s is equals to f of s, the function is what? Even. So we can now proceed. We have tested for even. Let's test the second example. Have any question? Sorry. So the second example, so state if this function, example 2, g of x is equals to what? Minus s raised to power 3 plus 2x minus 9. So the first thing is to replace g of x with g of minus x and simplify. Replace it and simplify. So g of minus x is equals to minus s raised to power 3 plus 2 minus x minus 9. So since it's odd, minus s raised to power 3 is equals to what? Minus s raised to power 3. Multiply it by minus 1, that will give us s raised to power 3 plus s raised to power 3. Because any number with a negative sign to the exponent of odd number, the result is equal to the, when you multiply it by its exponent, it is the same result. So with the same result, opening bracket, minus minus will give us plus. So plus 2 times minus x will give us minus 2x minus 9. So now from here we observe that minus x, this is what we have. So looking at the function, they are not the same. This is not equal to what? G of x. So this is not equal to g of x. There is plus here, there is minus here, there is minus here, and there is a plus here, there is minus here, there is no minus here. So g of minus x is not equal to what? G of x. So we can now conclude, therefore, we can now conclude that g of minus s, if this function is an even function, it must be, you can say since g of minus s is not equal to g of x, you put in bracket even. I hope you are seeing it, even function. And g of minus x is not equal to minus g of x. This is what? For odd. Since this is not equal to negative, g of x is not equal to g of x even, and g of x negative is not equal to negative g of x odd, therefore g of x is neither of the two. It's neither. Therefore the g of s is neither even or odd. I hope you are seeing it. So g of s is neither even or odd function. That is an example that explains the concept of neither of the given functions. So let's do one example. This is, we are testing for even odd characteristic of a given function. So let's do the last example and then we proceed. So the third example, example 3. Example 3 is f of x. If you are given f of x equals to s raised to power 5, f of x equals to s raised to power 5 plus 3s raised to power 3 minus x. So check if the function is even, odd, or neither. The first is to replace f of x with f of minus x. So f of minus x, this will give us minus x raised to power 5. I hope you are seeing it, 3 minus x raised to power 3 minus x. So from here you open bracket, this will give, like I've told you, this will give negative s raised to power 5. This will give us what? Negative 3 s raised to power 3. Negative will give us plus x. So from here, simplify further, we have f of minus x. Bring minus outside, minus 1. Bring minus 1 outside the bracket and open bracket. This will give us s raised to power 5 plus what? It will affect every sign. Once we bring minus outside, it will affect every sign in the bracket. If it's minus, it becomes plus. If it is plus, it becomes minus. So once you bring it out, this will be plus s raised to power 5 plus 3 s raised to power 3 minus x. So if you observe this, you see that this function is equal to this function. So this is minus f of what? X. Have any question? Observe the given function. If you observe these two, they are the same. This is equals to this. So I can replace it with f of x. That gives me minus f of x. So you can now state, therefore, since f of x is equals to negative f of x, the function is odd. It is an odd function. So we have tested for even, for odd, and also for neither. We can now proceed. Have any question? Although we have treated how to find all real zeros of the function, please me to give one example and then we now proceed to other things and finally conclude for today. Have any question? You are required to find the zeros of a given function. So how do you find the zeros of a given function? We have treated it broadly in preceding lectures we have. So you are required to find all real zeros of the function. Find all real zeros of the function. So you are given ag of x. ag of x is equals to 2 raised to power 3 plus 7s squared minus x, 5x minus 4. Any question? So we are given hg of x equals to 2s raised to power 3 minus 7x squared minus what? Minus 4. Sorry. So you can use the method of what? Rational root theorem, as we have done before. Rational root theorem to find the P over Q, the ratio of the constant and the leading constant. So the factors of P is plus or minus 1, plus or minus 2, plus or minus 4. And the factors of this is plus or minus 1, plus or minus 2. So, like I gave you a expo in the past, you use a remainder factor theorem to check for, because this is 4, this is 2. They have one factor in common. So if you check plus or minus 1 using factor theorem, we state that if x is equals to 1 or s minus 1 is a factor of a given polynomial, f of 1 is equals to 0. If you substitute wherever you see x, is substitute 1. If the result is equals to 0, then s minus 1 is one of the factor. So we can now proceed. So let's quickly use remainder theorem to check, because in this case you can use any method. So let's substitute 1 here. H of 1, this gives us 2, 1 raised to power 3 plus 3 plus 7, 1 raised to power 2 minus 5, 1 minus 4. This gives us 2 plus 7 will give us 9. Minus 5 minus 4 will give us 9. So 9 minus 9 will give us what? 0. So in this case, we now know that x is equals to 1 is one of the 0 of this function, and s minus 1 is one of the factor of a given function. So from here we can now use synthetic method to find what? Other roots. This is like revision. Synthetic method to find the other root, knowing fully that x is equals to 1 is one of the 0 of the function. So from here I now put 2, 7 minus 5 minus 4. So bring 2 down. Once you bring 2 down, so 1 times 2 will give us 2. You write it here, sum. This gives us 9. So 1 times 9 will give us 9. You sum. This gives us 4. 1 times 4 will give us 4. You sum. This gives us 0. So arrow is equals to 0. So once we have arrived at this point, you can rewrite hg of s in factor form. Write hg of x in factor form. That gives us hg of x equals to s minus 1, one of the already known, in bracket. This is 3, so this will begin with 2. 2 raised to power 2 z naught plus 9x plus 4. So once you came to this side, you can now factorize the quadratic. Multiply the first and the last term to give us plus 8s squared. Find two numbers that will give us 9x. If you multiply it, it will give us 8s squared. So we can test 8x plus x. This will give us what? 9x. So we can replace here with 9x. you can now replace 9s with 8s plus x. So from here we have 2x squared plus 8s plus x plus 4. So you factorize what is common. 2s is common, you bring it out, you open bracket, you have x plus 4. What is common? Plus 1 is common. So you close bracket, s plus 4. So once you arrive at this point, you collect like terms. If you collect like terms, you have what? S plus 4, 2x plus 1. You can now bring this down, s minus 1. You can now write it. I hope you are seeing it. So this is how you can do it. So you have already factorized it. The next is to do what? Find the zeros. So HG of x equals to 0. Once HG of s is equals to 0, s is equals to what? 1. S is equals to what? Minus 4. And s is equals to what? Minus 1 over 2. So these are the zeros of the given function. Any question? If you don't have any question, we can now go to what we before we conclude. So this is how you can find the zeros of any given real zeros of a given function. This is the method you can use. By factor method, you substitute based on trial and error to test. Then, or you can as well apply the method of rational root theorem to find the common fraction. But it's always interesting when if the 4 and 2 they have a common factor. When you see equation of this type, easily test for a whole integer real zeros, a whole integer real zero, that is 1, 2, 3, before going to fraction. Except when you look at them, maybe you see 7 here, you see 2 here, then apply rational root theorem, because they don't have any factors in common. Although 1 is, you can test for 1, but apart from 1 there is no other factor that is easily you can see easily. So you apply the factor rational root theorem. But if they have something in common, you can apply factor theorem to see. Maybe you test 2, 3, 1, maybe you test 2, 1. Test 1 first, plus or minus, before going to 2 and 4. So this is one of the secrets. If it's odd, you go for odd. Maybe test 3, test 1, odd numbers before you go to even. So please do this one. Do this and submit it to me. We are given f4 of x equals to 2x raised to power 3 minus 3x raised to power 2 minus 32x minus 15. Find the zeros of this function. If you like, you can use your calculator to see the zeros and then solve it. Find the zeros of this function. Use any method we have treated so far to find the zeros. Have any question? No question. So finally, match the function with its graph. Match the function with its id graph. So the first function is f of x is equals to s minus 1, s minus 2, s plus 2. Then the second one, second function, we are required to do what? Match the graph with its function. ag of x is equals to what? s plus 2 squared s plus 1 s plus 1. I hope you are seeing it. So the third, g of x is equals to s plus 1, s minus 1, s plus 2, and the fourth one, the fourth is what? f of x is equals to s minus 1 squared s plus 2. So what the question stated, match the function with its graphs, with its accurate graph. So we have the first graph. This is the first graph. The graphs look like this. This is how the graphs look like. So this is intercept. We have one here, we have another here too. Here is minus 1, here is minus 2, I have minus 3. This first graph. So the second graph, it looks like this. This graph looks like this. Here we have what? We have minus 2. Here we have 1. We have 2. I hope you are seeing the graph. So this will be like this. Here we have 2. I'm giving you the graph. Here we have minus 1. I hope you are seeing it. This is minus 2. Here is minus 3. So the third one, number C, you put it like this. This is the third graph. Here at this point you have minus 2. Here you have minus 1. Here is 0. Here is 2. Here is x. Here is y axis. You can state it very well. They are the same as this. There is no different. Here is minus 2. And lastly, you have a graph that looks like this. Here is minus 2, minus 3. Here is minus 1. Here is 1. Here is 2. There is an intercept. Very clearly, this is an intercept. The intercept of here is 2, and here is 1. So once we have plotted the graph, the next thing is to do what? Look at the function given. So you can now look at the function, match the function with its graphs. The first one, look at the first one. How can we match it with its graphs? We have some here, we have 3 here, we have 1. So this is what we are required. Match the function with its graph. So let's go for the first one. To do that, to find the y-intercept of the graph, so what can we do? Y-intercept, we are in number 1 of the graph. To find the y-intercept of the graph, put s equals to 0. S is equals to 0. Or multiply the constant -1 minus 2 plus 2. -1 times -2 times plus 2 will give us what? This will give us -1. This -1 times -2 will give us plus 2. Plus 2 times plus 2, this will give us what? Plus 4. So look for graph that has plus 4 interval. We look around. This is 2. That is interval on the y-axis. F of s is in the y-axis. Look for any graph that has interval on the y-axis. This looks promising. So the next thing is to find what? The 0 of the function. After all, these two seems to be possible. So to clarify the air, in order to get the graph of this, any of these, you have to know the y-intercept and the zeros of the function. So how do we get the zeros of the function? F of x will be equal to 0. So if we make f of s equals to 0, we get the x is equals to what? 1, 2, and -3. So look for intercept on this. -3. Is there anyone with what am I saying? This is the graph, sorry. So make it 0. If it is 0, we have -1, -2, -1. We have, once we make f of s the 0, we have s equals to what? 1. Crosses equal sign. This crosses the other sign, give us 2. This crosses give us -2. So these are the zeros. Look for graph that has these zeros. This look promising. We have 1, we have 2, we have -2, including the 4 we have earlier. So this graph is for 1. So for the 2, I hope you are seeing what I'm doing. Use 2 concepts to locate the graph. First, the y-intercept, and second, the zeros of the function. So here, the y-intercept will be what? S will be equal to 0. H, when s is equals to 0. If s is equals to 0, we have what? 2 raised to the power 2 times 1. 2 raised to the power 2 times 1 will give us what? 4. Is it not? So h of x will be equal to plus 4. Look for graph that has plus 4 at the y-intercept. This will look promising. Here we have 2. I hope you are seeing it. So the next thing is to check the zeros. So to take the zeros of this, h of x will be equal to 0. Then s will be what? S will be equal to -2 twice. What do I say about repeated root? Repeated root, when s is equal to any number twice, it means it touches the s-axis but does not cross it. So look for graph that touches the s-axis but does not cross it. This touches at 1, it doesn't cross it, and this touches at 2, -2, and it touches it doesn't touch it. Then the last one is when s is what? -1, which is -1. I hope you are seeing it. This touches the graph, the s-axis, but it doesn't cross it. This also touches, but it doesn't cross it. But we are talking of -2. So this has a repeated root. Therefore, this one is for 2. here must be 4. I hope you are seeing what I'm doing. You make s equals to 0, you find the HU of s, which gives us 4. Find its zeros by making HU of s equals to 0. That gives us minus 2 twice and s equals to minus 1. This graph has that properties, minus 2 and 1 and 4. So I've gotten the second one. So let's find the 3. So to do that, put s equals to 0, we have 1. If s is 0, we have 1. 1 times minus 1 times plus 2. So this will give us what? Minus 2. So HU of x is equals to minus 2. Look for graph that has y minus 2 in intercept in the y-axis. B has minus 2. Is it not? So, but we have to find its zeros. So to find the 0, let g of x equals to 0. If g of s is equals to 0, s will be equal to what? Minus 1, 1, and minus 2. So since it has minus 2, let's go there and check its zeros. Minus 1, minus 2, and the 1. So this graph is for 3. I hope you are seeing what I'm doing. And lastly, although 1 left, so we can assign it to 4, but we have to check it. So let's go. Any question? So for 4, s will be equals to 0. When s is equals to 0, we have minus 1 squared times 2. So this gives us what? 2. Minus 1 squared is 1 times 2, 2. So f of x is equals to what? 2. Look for graph that has intercept on the y-axis, that is 2. This has 2 intercept on the y. So check is 0. To check is 0, f of x is equals to 0. S is equals to what? 1 and the what? And minus 2. So check it, we have 1 and minus 2. So this graph is for 4. So use this concept of checking for intercept and the zeros to do the exercise in your textbook. If you have any question, refer to me for the solution, and then I will provide the answer for you. See you in the next lesson. Bye for now.